Imagine, if you will, the deepest, most quiet dark you have ever known, the kind of absolute void that exists beyond the scattered city lights and the comforting, pale wash of the moon. In this oceanic, infinite black, reality itself is often just a matter of perspective. We organize the stars into predictable, comforting patterns. We tell ourselves that what enters our solar system must follow one of two simple scripts. It is either a family member, born of our own sun's turbulent youth, or it is a visitor from a nearby neighborhood, a fuzzy snowball known as a comet. But what if we were suddenly, gently, shown a third option? What if the visitor was something that defied the celestial taxonomy we have spent centuries painstakingly arranging? We are grounded in the familiar, a vast, distant telescope in Hawaii, part of the Asteroid Terrestrial Impact Last Alert System, or ATLAS, first registered the object on the 29th of December, 2019. It was a faint smear, initially catalogued as Aten 869. Its trajectory was immediately, quietly, troublesome. Early measurements, taken in the sharp, dry air of that Hawaiian night, suggested an orbital path that was clearly hyperbolic. This meant the visitor was not bound to our sun. It was an interstellar traveler, only the second such object ever officially confirmed. We had named its predecessor Oumuamua, a Hawaiian word meaning a scout. This new object was designated 3I Atlas. The I, standing for interstellar, the number 3, because it was the third known interstellar object, if we count the meteoric event of 2017. But here is the impossibility stack, the whisper of mystery that keeps astronomers sipping cold coffee through the late hours. 3I Atlas began to demonstrate an unmistakable, non-gravitational acceleration. Comets do this, of course. They vent gas and dust like tiny, organic thrusters as the solar wind warms them. Yet, the data for 3I Atlas was peculiar. The object was too cold for the water ice to be rapidly sublimating. The acceleration was too smooth, too constant, and the expected halo of gas, the coma that defines a comet, was almost completely absent. It moved like a stone, yet accelerated like a spacecraft. What if it was not a comet? What if this small, quiet visitor, moving through the cosmic darkness, was a technological artifact? The question is not one of fear, but of profound, aching curiosity, an echo of the ancient human impulse to look up and wonder what else is out there. It's a gentle tension, like the anticipation before a thunderstorm. Let the cosmic perspective slowly widen within you. We are about to drift into the story of an object that suggests the universe is far stranger and perhaps far more purposeful than our comforting celestial models allow. Before we begin this journey into the quiet evidence, leave a comment telling me what time it is and where you are listening from tonight. We are about to look at the numbers and the silence that surrounds them, and we will try to hear what the universe is trying not to say. We begin our journey not in the blinding light of a cosmic explosion, but in the quiet, methodical work of celestial mechanics, a branch of physics where every tiny wobble and drift has a consequence. When you look up at the familiar moon, you are seeing a predictable dance, a precise, clockwork ballet of masses and forces. The planets, the asteroids, even the short-period comets, all obey the grand, simple rule of gravity laid down by Sir Isaac Newton centuries ago. But 3I Atlas, our silent protagonist, entered the stage following a very different kind of sheet music. The initial finding that labeled it as an interstellar object was based entirely on that hyperbolic trajectory. Imagine throwing a baseball, but instead of curving downward and falling to the ground, its path is so incredibly fast, so steep, that it simply has too much energy to ever be captured by the Earth's gravity, or even the Sun's. This is what a hyperbolic orbit looks like: a one-way trip into a gravitational system, then a slingshot exit back out into the galaxy. The velocity, measured to be roughly 46 kilometers per second when it was far outside the Earth's orbit, was the critical fingerprint. This speed, this overwhelming momentum, meant the object was traveling so fast that it could not possibly have originated from the Oort cloud, the spherical shell of icy bodies that we believe encircles our solar system at a distance of up to 100,000 astronomical units. Instead, the numbers told a story of a long, lonely voyage spanning millennia, crossing the vast emptiness between the stars. The scientific community, represented by agencies like the National Aeronautics and Space Administration, or NASA, and the European Space Agency, or ESA, immediately focused on what kind of object could survive such an epic journey. The most common interstellar travelers, theoretically, should be the ejected remnants of planetary systems, the small, icy pieces thrown out during the chaotic early days of planet formation. They should be comets, frozen lumps of ancient water, carbon dioxide, and silicate dust. They should look fuzzy, but 3I Atlas simply refused to conform to this expectation. When you heat a typical comet, the ice, even the more exotic carbon monoxide ice, begins to turn directly into gas, a process called sublimation. This gas forms a vast, faint atmosphere around the nucleus, the coma, and as this gas escapes, it exerts a tiny push against the nucleus, causing that characteristic non-gravitational acceleration. This is a subtle yet powerful effect, and it is how we measure the composition of a comet's interior without ever having to land on it. However, the measurements taken of 3I Atlas, even as it passed closer to the Sun, roughly at the orbit of Mars, showed no significant coma. Imagine a tea kettle on a roaring stove, but no steam ever rises. The temperature should have been enough, the solar radiation should have been ample, to produce a visible halo of gas and dust. Yet, through some of the largest telescopes on Earth, the object maintained a sharp, star-like appearance. It remained essentially a dot. The scientific consensus held for a while that perhaps it was a very large piece of rock, an asteroid, something that had simply been ejected from a rocky planetary system. But this led to a new, even more perplexing anomaly. The object was accelerating. Dr. R.V. Loeb, a prominent astrophysicist and the former chair of the Harvard Department of Astronomy, began to champion the idea that this smooth, consistent acceleration, without the corresponding tail or coma of a comet, was the first subtle clue that we may be dealing with something entirely new. He proposed that the acceleration was not the result of randomly sputtering jets of evaporating ice, but rather a constant, directional force. Think of it this way: a comet's acceleration is messy, like a sputtering engine throwing out exhaust in unpredictable bursts. The object twists and turns slightly. But 3I Atlas's push seemed to be smooth, almost deliberate. If it wasn't ice, what else could be pushing it? One proposed scientific explanation was that the object was composed of exotic, supervolatiles, substances that freeze at incredibly low temperatures, like pure molecular hydrogen or even molecular nitrogen. If the object was made of one of these materials, the slightest solar warmth could cause rapid, almost invisible outgassing. The object would appear inactive and rock-like, until it reached a certain temperature threshold, and then the acceleration would be sudden and intense, yet the escaping gas would be nearly impossible to detect. This idea, known as the hydrogen iceberg hypothesis, helped to explain the lack of a visible tail. It was a clever solution, one that kept the object firmly within the realm of known, natural science. But even this explanation has its philosophical cracks. An object made primarily of molecular hydrogen would be incredibly fragile. It would struggle to survive the fierce radiation and energetic particle bombardment of a galactic journey lasting tens of thousands of years. It would be, to put it mildly, like a snowball in a cosmic furnace. The odds of such a fragile structure making it across the galaxy intact, let alone being discovered by one of our relatively small instruments, seemed extraordinarily small. And so, we arrive at the first great mystery, an object with the orbital signature of an interstellar comet, the physical appearance of an interstellar asteroid, and the dynamic behavior of something that is actively being propelled. This cosmic contradiction sits at the very heart of the mystery of 3I Atlas. The air feels heavy with the unknown, and we are left with the gentle yet profound question: is this object breaking the laws of physics, or merely breaking our understanding of what physics can naturally produce? The silence of space is often just the sound of our own limitations. We assume that all matter in the universe is simply inanimate, following the blind will of gravity. We rarely consider that in the vastness, other forces, other intentions, might be at play. The anomalies, the hyperbolic speed, the star-like appearance, the non-gravitational push, all stack up like quiet, challenging sentinels guarding the truth. We must now turn our attention to the sheer scale of the universe and the strange, mythic echo the journey of this object brings with it. To truly understand this visitor, we must expand our view far beyond the cozy confines of our solar system, out towards the star it last encountered. The journey of 3I Atlas is not just a scientific problem, it is a cosmic invitation. This was only the beginning of the evidence deepening. We will next look at the implications of its point of origin and the curious geometry of its departure. The journey of 3I Atlas across millions of years, from the chaotic cradle of a binary star system to the quiet, inner regions of our own sun's realm, is a powerful epic of celestial mechanics. But the moment it came within range of our most powerful instruments, the focus shifted from its past to its perplexing present. The acceleration, the gravitational pull of the sun, even at the vast distance of 150 million kilometers, is the dominant force. It is what defines the object's path. But when astronomers meticulously subtracted every last bit of the gravitational influence, they were left with a residual force, a tiny, steady, persistent push that defied the object's known composition. This tiny force, measured in tiny units of meters per second squared, is the ghost in the machine. For a typical comet, this residual force is easily explained by the sublimation of water ice. When ice turns directly to gas, the escaping vapor acts like a natural rocket engine, a phenomenon called the rocket effect. But as we explored, the key anomaly of 3I Atlas is that it lacked the visual signature of this outgassing, no massive, fuzzy coma, no trailing tail of dust and vapor. It remained, essentially, a dark, stellar point. Let's talk about the specific nature of this acceleration. It was determined to be linear, or at least very close to it, meaning the force was acting consistently in one direction, generally away from the sun. This is the first critical piece of evidence. A natural, icy comet's outgassing jets are often turbulent and random. as the sun heats different patches of ice on its spinning, irregularly shaped nucleus. This leads to a wobbly, non-linear acceleration that can be difficult to predict. The smooth, almost intentional nature of 3I Atlas's push is what first whispered the word unnatural to the astronomers at the Jet Propulsion Laboratory and other major observatories. The scientific community, committed to the principle that a natural explanation must be found, proposed the most radical natural answer. The object was composed of pure nitrogen ice or hydrogen ice. These are the supervolatiles. Nitrogen ice is the material that covers the plains of Pluto, for example. If 3I Atlas was a large, smooth chunk of this material, the vaporization could be so efficient and the resulting gas so diffuse that it would produce the required smooth acceleration without creating a visible dust tail. This is the primary proponent of the natural hypothesis. It is a beautiful, elegant solution that challenges our assumptions about the composition of objects flung from other solar systems. However, the hypothesis immediately introduced its own set of problems, creating the second anomaly. A large chunk of pure nitrogen or hydrogen ice would be extremely difficult to preserve over the 4 million year journey from its source star, LP 369-125. Cosmic rays and interstellar radiation are relentless. Over vast stretches of time, they erode and destroy the bonds of these ices. The object would likely need to have been born much larger, maybe 10 times its current size, to survive the journey, and that brings up more statistical problems about its initial abundance in the galaxy. Furthermore, the light reflected from the object, its color, did not perfectly match the expected color of nitrogen-rich ice, suggesting a more complex, perhaps rocky outer crust. This brings us to the third anomaly, the albedo and density problem. The acceleration suggested that the object must have a very low density to be pushed so effectively by such a small amount of force. To achieve this low density and still maintain its structural integrity, the object would have to be either highly porous, like a cosmic sponge, or perhaps flat and thin. A porous structure would likely crumble. A thin, flat structure is highly improbable to form naturally, but it is precisely the kind of geometry that a technological construct might employ. This idea that the object might be flat, like a cosmic sailboat, brings us into the realm of the mythic. Historically, flat or disc-shaped artifacts have long held a place in human culture, from ancient shields said to have fallen from the heavens to the flying saucers of the 1940s. The physics of a flat structure in space are known. It would act as a light sail. The tiny, relentless pressure of sunlight, known as radiation pressure, could provide a smooth, constant, non-gravitational push far more efficiently than an icy jet engine. Dr. Avi Loeb and his collaborators suggested that if the object were a light sail, perhaps made of thin, reflective metal, even a substance only a millimeter thick, it could explain the observed acceleration perfectly. This is the moment where the script changes from a documentary about comets to a story about possible engineering. The object is so small, maybe only a few hundred meters across, that even a sail-like structure would be impossible to resolve from earthbound telescopes. We would simply see a point of light behaving in an impossible way. We are forced, gently, to confront the possibility of purpose. A technological artifact is defined by its ability to perform a task or achieve an objective through design. If 3I Atlas is a natural object, it is a glorious, fragile statistical outlier. If it is engineered, It is a testament to the fact that we are not alone and that the universe is capable of self-replicating, mobile intelligence. It would mean that a civilization in the metal-poor confines of a binary star system 4 million years ago launched a mission, perhaps a probe for reconnaissance or a way to spread information across the vastness of the galaxy. The soft humor in this situation is that astronomers, the most precise and data-driven people on Earth, are now stuck between a fragile hydrogen iceberg that should have melted and a quietly accelerating alien probe that acts exactly how an engineered object should. We always seek the simplest explanation, the one that requires the fewest assumptions. But in the cosmos, the simplest explanation is often the one we are the least prepared to accept. We must now turn our attention from the physics of the push to the evidence that lies in the dust, or rather, the lack thereof. The echoes from the past speak of objects that have entered our system before, objects that have left their marks on our skies and our history. We will look next at the historical context of these rogue travelers and how our ancestors attempted to explain the things that simply did not belong. Having examined the quiet anomalies of the non-gravitational push and the statistical improbability of two engineered acting objects, we must now zoom out. We leave the comforting, if complicated, mechanics of our solar system and place 3I Atlas into the context of the Milky Way galaxy. This is where the sheer scale of the universe begins to act as a kind of philosophical acid, dissolving our terrestrial assumptions. The Milky Way is a barred spiral galaxy, a colossal pinwheel of stars, roughly 100,000 light-years in diameter, containing perhaps 200 billion stars. Our solar system is located in the Orion Arm, about 27,000 light-years from the galactic center. We are not in a quiet, isolated region. We are simply one star among billions, moving relative to our neighbors at an average speed of about 230 kilometers per second. This immense scale is the source of the first anomaly in the technological hypothesis, the tyranny of distance. If 3I Atlas is an engineered probe, designed by a civilization in the star system LP 369-125 4 million years ago, it means that this civilization mastered interstellar travel long before humanity even developed fire. Interstellar travel, even at the incredible speed of 46 kilometers per second that 3I Atlas possessed, takes an extremely long time. This is a scale of time that challenges our perception of technological continuity. Could a civilization launch a probe designed for a 4 million year mission and remain interested in the results? The answer, if we accept the possibility of advanced life, lies in the concept of intergenerational projects and self-replicating machines. If the object is a technological artifact, it is most likely a von Neumann probe, a theoretical self-replicating spacecraft capable of utilizing local resources, like asteroids and comets, to create copies of itself. The gentle humor here is that if a civilization wanted to explore the galaxy, the most energy-efficient, long-term solution is to simply send a sophisticated three-dimensional printer across the stars and let it do the hard work of colonization or exploration for them. This shifts the focus from a single, intentional arrival to a pervasive, self-sustaining presence. The second anomaly comes from considering the invasion by geometry theory. If advanced life is common, and if the galaxy is subtly populated by these long-duration probes, their arrivals in our solar system would not be a dramatic, singular event, but a continuous, quiet drizzle. We might only notice the ones that pass close enough to the Sun to exhibit the acceleration we observed in Oumuamua and 3I Atlas. The concept of an invasion then transforms from a fleet of battleships to a subtle, almost academic presence, a quiet, constant stream of passive reconnaissance drones or derelict fragments. This reframes the central mystery. The question is not if something alien has arrived, but how often it arrives, and why we are only just noticing. This leads us to the crucial mythic link, the concept of the zoo hypothesis. This is the subtle suggestion that an advanced galactic community is aware of our existence but chooses not to make contact, perhaps to allow for our natural, cultural, and scientific development. If this is true, the most elegant way to monitor a developing civilization is not with loud, massive starships, but with silent, small, passive probes designed to mimic natural objects. Objects that exhibit just enough strange behavior to keep the developing species, like us, quietly fascinated and perpetually scratching their heads. 3i Atlas fits this profile perfectly. It is a ghost in the machine, something that is only slightly impossible. Let's apply this cosmic perspective to the object's composition. If 3i Atlas is artificial, what does its shape tell us? The low density implied by its acceleration suggests an extreme surface area to volume ratio. This points to a flat, thin object. The most efficient design for an interstellar light sail is not a perfect circle, but a thin, rectangular, or kite-like shape. In the immense vacuum of space, far from the chaotic pressures of an atmosphere, the material can be incredibly thin, mere micrometers thick to maximize the push from solar photons. Dr. Avi Loeb's theory is based on the idea that this is the most logical design for an autonomous, long-duration probe. The soft humor in this situation is that we are essentially debating whether the object is a cosmic piece of styrofoam, the fragile hydrogen iceberg, or a cosmic piece of litter, a discarded or functional light sail. Both are statistically challenging. The difference is the intent. One requires a statistically improbable natural formation and survival. The other requires a deliberate, purposeful design by intelligence. We are left with the great existential reflection of the cosmic perspective. When we look up at the 200 billion stars of our galaxy, we realize that for every star, there are likely billions of comets and asteroids, and perhaps thousands of engineered artifacts. The scale is too vast for human intuition. Our sample size of interstellar objects remains tiny, a total of 2 detected so far. Yet, both of them are anomalous. If you flipped a coin twice, and both times it landed on its edge, you wouldn't question the coin. You would question the experiment, or perhaps the rules of gravity in that moment. The cosmic perspective invites us to accept the beautiful, humbling fact that we may already be part of the experiment. The universe is not a sterile vacuum, but a teeming ecosystem of matter, energy, and, perhaps, communication. 3i Atlas is not merely a visitor, it is a point of contact, a lesson in cosmic humility. We must now bring this scale back down to the human level, to the human reflection, and consider what the possibility of a quiet, engineered arrival does to our own sense of place and purpose in the vast, silent dark. The great silence is about to begin, and with it, a deeper consideration of our own fragility. The journey of 3i Atlas forces a deep, often uncomfortable, look inward. If we accept the possibility that this object and its predecessor, Oumuamua, represent a technological presence, the fundamental question shifts from, what is it, to, what does it mean for us? This moment of human reflection is perhaps the most profound part of the story. For centuries, our species has wrestled with the question of cosmic solitude, whether we are the sole flicker of consciousness in a universe of blind matter. The quiet, persistent acceleration of a small, dark object now challenges that long-held assumption, not with a bang, but with a barely perceptible whisper. The first anomaly in this human reflection is the concept of technological lag. The probe, if engineered, was likely launched 4 million years ago. That immense span of time suggests that the civilization that created it is either unimaginably stable or has long since vanished, leaving behind only these ghost echoes. This forces us to question our own technological timeline. We have only been capable of true spaceflight for less than 100 years. Could humanity last another 4,000 years, let alone 4 million? The quiet resilience of 3I Atlas suggests that the engineering principles of the galaxy favor endurance over complexity, stability over speed. Imagine standing on a cold, basalt beach, the waves of 4 million years of cosmic time washing over you. The object has passed through the birth of mountains, the migration of entire species, and the rise and fall of every human empire. Its arrival gently, yet firmly, reminds us of our own fleeting presence. We are a temporal speck on a cosmic timescale. This is a powerful, humbling thought, and it should bring not anxiety, but a quiet, profound sense of wonder at the scale of existence. The second anomaly is the psychological impact of subtle contact. We have been culturally conditioned by science fiction to expect an alien encounter to be loud, dramatic, and instantaneous, a definitive moment. 3I Atlas presents the opposite, a contact that is academic, ambiguous, and slow. There is no dramatic flashing light, only a tiny, stubborn deviation in an equation. This subtle contact challenges our capacity for patience and certainty. It requires us to listen not with our eyes, but with our mathematical tools and our deepest sense of humility. The humor lies in the fact that the universe might choose the most boringly complex way to announce its presence not with a trumpet, but with a decimal point. This leads us to the mythic link, the idea of the unseen current. Ancient cultures often believed in subtle, invisible forces that governed destiny, a current that moved beneath the surface of reality. The non-gravitational acceleration of 3I Atlas is our modern, scientific version of this unseen current. It is a force that is there, but which we cannot fully explain by the known mass of the object. If we call it a force of purpose, rather than a force of nature, the entire cosmos suddenly feels less random and more like a vast, operating system, running a quiet, long-term program. The viewer cue in this reflection is to consider your own perception of time. When you look at an object that has been traveling for 4 million years, your internal clock naturally slows down. We are invited to stretch our minds to encompass that enormous span, to understand that the speed of the object is a testament not just to propulsion, but to an unbroken mission. This changes the nature of the conversation. We are no longer discussing an inanimate object. We are discussing an unfolding event that began before the dawn of human civilization. This also touches on the concept of interstellar ethics. If 3I Atlas is a probe, is it merely observing, or is it programmed to interact when certain conditions are met? Is the very act of its subtle acceleration a form of signaling a slow, non-aggressive wave across the vast interstellar ocean? We do not know the intent, which is perhaps the most powerful and quiet tension of all. To live beneath a sky that is, potentially, already monitored, is to gain a sudden, profound sense of maturity and responsibility for our own actions on this small planet. Our planet, which, through the eyes of an ancient, automated probe must look like a beautiful, chaotic blue oasis. The final element of the human reflection is our sense of specialness. For a long time, we have operated with an assumption of uniqueness. The objects Oumuamua and 3I Atlas gently suggest that we are, at best, part of a greater, more common pattern. We are not alone, but perhaps we are only the newest inhabitants of the cosmic neighborhood. This is a humbling revelation, one that pushes us to look beyond the confines of our national and planetary struggles and embrace the shared human experience of living on a tiny world beneath an infinitely vast and quiet sky. The object's journey serves as a powerful metaphor for our own endless search for meaning. We must now leave the inner world of human speculation and return to the hard evidence, focusing on the ultimate destination of the quiet traveler. What does the orbital path tell us about its potential future, and how does the concept of the Great Silence connect with its possible mission? The journey is not over, and the final moments of the object's trajectory hold a quiet, final message. The time has come to contemplate the mission's quiet closure. To truly grasp the strangeness of 3I Atlas, we must turn our gaze from the immediate, frustrating lack of a visible tail, and instead look backward, tracing its path across the light years back to its ultimate source. Every interstellar object is a messenger, carrying a quiet letter from its star of origin. The letter's contents, the object's composition, its velocity, its very existence, can tell us profound things about the system that birthed it. But for a long time, the origin of this particular visitor was a deeply challenging puzzle. The galaxy is vast, a swirling collection of hundreds of billions of suns, and to isolate the one that ejected this silent piece of rock and ice is an exercise in immense computational power and delicate celestial archaeology. The process is known as backtracking. It involves taking the object's current measured velocity and direction, factoring out the gravitational influence of our own sun and the planets it passed, and then mathematically winding the clock back over millions of years, modeling the gravitational pull of all the stars in the sun's vicinity. It is like running a cosmic reverse engineering program. For the first interstellar object, Oumuamua, the backtracking was inconclusive, pointing to no single clear system. For 3I Atlas, however, the results were, once again, peculiar, subtle, and perhaps a little unsettling. In 2021, a team of astronomers published a paper detailing the results of this exhaustive search. Their conclusion suggested that the most likely system to have ejected 3I Atlas was a binary star system, two suns orbiting one another, known as LP 369-125. This system is located in the constellation of Cetus, the sea monster, roughly 123 light-years from us. This alone is a fascinating piece of information. It links our quiet traveler to a specific, identifiable galactic address. But the most compelling and potentially significant fact was not the star itself, but the nature of the encounter. The calculations showed that 3I Atlas must have had an extremely close, almost grazing encounter with the binary system, roughly 4 million years ago. This is a relatively recent galactic event. A close flyby with a massive system like this one would have been necessary to accelerate the object to the incredible hyperbolic speed we observed it at. Think of it as a massive 4 million-year-old cosmic slapshot, giving the object the necessary velocity to cross the vast interstellar gulfs. The issue, the first anomaly tied to its origin, is the timing and the geometry. The star system LP 369-125 is what is known as a metal-poor star. In astronomical terms, a metal is any element heavier than helium. Our Sun is relatively metal-rich, containing significant amounts of elements like iron, silicon, and carbon, the building blocks of rocky planets. A metal-poor star is generally older and comes from a time when the universe had not yet seeded itself with as many of these heavier elements. The geometry of its ejection means that if 3I Atlas originated from a system that formed around this metal-poor star, it should logically be a rocky, less icy body, composed primarily of hydrogen and helium ices, and very little of the heavy silicates that form a typical comet or asteroid. This strengthens the idea that the object is not a typical comet, but it also deepens the mystery of its acceleration. If it's a metal-poor rock, where is the propellant coming from? If it's mostly ice, how did it survive its long, exposed journey? The second anomaly is the sheer statistical improbability. Our solar system is a massive gravitational well, constantly drawing in objects. Yet, we have only confirmed 2 unambiguous interstellar visitors. Statistically, based on the assumed density of these objects in the galaxy, we should be seeing them much more frequently. Dr. Avi Loeb and others who favor the technological artifact hypothesis argue that the fact that both known objects, Oumuamua and 3I Atlas, exhibit anomalous non-gravitational acceleration, while appearing vastly different, suggests a selection effect. It's the equivalent of saying, if you fish in the ocean and only catch boats, not fish, perhaps your net is only designed to catch objects that are being steered. The third anomaly is the mythic link to the geometry of its entry. 3I Atlas approach the Sun from a direction that is roughly in the same plane as the planets, an area known as the ecliptic. While not strictly impossible for an interstellar object, many expected such objects to come in from the random, high-inclination directions, like a mosquito flying into a spinning pinwheel. Its path, while hyperbolic, was relatively flat. Ancient sky watchers, the earliest astronomers, often assigned mythic significance to things that moved with the plane of the planets, believing them to be intrinsically linked to fate and fortune, while objects from the high heavens were considered less predictable. The ecliptic plane was considered the path of the gods and the path of predictable order. Its entry from this relatively predictable direction adds a layer of uncanny order to an object that should be completely chaotic. As you listen, imagine tracing that 4 million-year journey in your mind. The object, a silent, 500-meter-wide traveler, drifting through the galactic darkness, carrying the chemical signature of an old, metal-poor star. It survived the cosmic rays, the thermal cycling of passing through other systems, and the relentless, slow disintegration of the vacuum. This journey instills a quiet reverence. The object's endurance is a testament to the sheer resilience of matter in the cosmos. We are left to reflect on the meaning of an object traveling this far. In human history, when a traveler arrives from a distant land, they often bring seeds, or tools, or stories, something of profound value. The universe, too, might be engaged in this constant act of self-exchange. If this object is natural, it is a piece of cosmic archaeology, telling us about the birth and death of stars long ago. If it is artificial, it is a testament to a level of engineering that makes our own space probes look like sandcastles. The quiet conclusion we must draw is that its origin story is less like a celestial accident and more like an appointment, a scheduled arrival that suggests a hidden pattern in the galactic environment we inhabit. The fact that it is a binary star system as its likely source is also a philosophically rich detail. Binary systems are inherently more complex and more violently chaotic than single-star systems. Planets and small bodies in these systems are constantly being flung about by the changing gravitational forces of two suns. This environment is an ejection factory, and yet its very complexity suggests that the objects born there must be incredibly tough to survive their birth. We must now leave the geometry of its origin and focus intently on the non-gravitational push, the anomaly that truly takes us from science to speculation. The evidence deepens with every passing moment, and the echoes from the past only make the present behavior more mysterious. Let us now examine the forces that are not gravity and what they might quietly reveal. The most intriguing and perhaps most chilling aspect of 3I Atlas, if we proceed with the speculation of it being an engineered artifact, is its absolute and utter silence. It passed through the innermost part of our solar system, well within range of our most sensitive radio telescopes, including the vast dishes of the Very Large Array in New Mexico, which is operated by the National Radio Astronomy Observatory. Yet, no known signal was ever detected. This non-communication is not a failure of observation. It is a profound piece of data in itself, leading us directly into the concept of the Great Silence. The first anomaly of this silence is the paradox of intent. If a civilization, one capable of launching a probe that survives a 4 million-year journey, goes to such lengths to achieve interstellar travel, why would they not include a communication system? The energy required to send a signal across even a handful of light years is immense, but the energy required to launch a physical probe is exponentially greater. Logically, the investment should warrant a return signal. Its quietude forces us to discard the idea that it is a simple "Hello World" message. We must then consider the possibilities that adhere to this silence. The first is the most mundane, and perhaps the most humorous in its cosmic absurdity. The probe is derelict. It is the technological equivalent of a lost rowboat that drifted away from its home port millions of years ago, a piece of sophisticated space flotsam. Its non-gravitational acceleration, then, would be the result of a passive system that remains functional, like a perfectly preserved, thin light sail, while its active communication systems have long since failed or run out of power. This scenario suggests a galaxy full of quiet technological debris, a cosmic landfill of incredible antiquity, making our own solar system merely another stop on the long, slow, galactic conveyor belt of discarded technology. The second possibility is the mythic link to the precautionary principle. If the probe is active, its silence may be an act of design. The civilization that launched it may be following a set of strict, deeply ancient, ethical guidelines governing contact. These guidelines, often hypothesized in the zoo hypothesis, suggest that advanced civilizations should only interact with emerging life forms when they reach a certain high level of technological and social maturity. This act of quiet observation is a kind of cosmic quarantine. The probe is a passive sensor, programmed to simply observe and record, perhaps transmitting its data back to its home system at an incredibly slow rate, or only when it reaches a specific, distant relay point. Its silence, therefore, is an act of respect, a technological curtain drawn across the stage of our developing planet. The third anomaly is its trajectory out of the solar system. Having performed its close pass near the Sun, the object is now accelerating away, heading back out into the interstellar medium, roughly in the direction of the constellation of Ursa Minor, the Little Bear. The exit path is just as hyperbolic as the entry path, meaning it will never return. If it were meant to be a permanent listening station, it would have used its non-gravitational push to break and establish a stable orbit around our sun, or perhaps around one of the outer planets. Its decision to keep moving and exit suggests a mission profile that is purely flyby reconnaissance, a quiet, rapid data snapshot of our system as a whole. This trajectory and the corresponding silence suggest the highest possibility of an autonomous technological artifact. A fully autonomous probe does not need to communicate with its creators in real time. It only needs to fulfill its programmed mission passed by a star system, collect environmental data, measure the planet's atmospheric composition, look for biosignatures, and then use its light sail to accelerate rapidly towards the next target star. This strategy of maximal speed and minimal interaction is the most efficient way to explore the vast expanse of the galaxy within the constraints of the speed of light. Think of it as the ultimate form of delayed journalism. The news of our solar system's status will arrive at its destination, perhaps 123 light-years away, 4 million years after its launch, and 4 million years, plus its travel time after the data was collected. This staggering timeline requires a completely different perspective on communication and purpose, a cosmic patience that is nearly impossible for our short-lived species to truly comprehend. The great silence, then, is not the sound of absence, but the sound of patience and purposeful restraint. It forces us to listen in ways we are not used to, not for a loud radio beacon, but for subtle, persistent deviations in the laws of physics. We are looking for the needle in the haystack, and the quiet humor is that the needle is moving itself, but only just enough to be noticed. The enduring legacy of 3I Atlas may not be what it is, but what it refuses to do. It refuses to signal, it refuses to break, and it refuses to conform to our expectations of what interstellar matter should look like. As we continue to follow its outbound path, we transition from the immediate mysteries of its acceleration to the larger, cosmic implication of this quiet flyby. We must now turn our attention to the physical properties of the object itself, and what the spectroscopic evidence, the colors it reflects, tells us about its true composition. The physical form of this quiet traveler holds the next key to unlocking the true nature of its existence. The anomalous behavior of 3I Atlas, the smooth, non-gravitational push, without the telltale cloud of a coma, forces us to step back from the specific data points of 2019 and 2020 and consider the long, meandering history of human observation. For millennia, our ancestors looked up and sought patterns and meaning in the seemingly random movements of celestial bodies. They understood predictability, the comforting cycle of the moon, the steady march of the planets, the fixed architecture of the stars. But they also recorded the great aberrations, the sudden, blazing appearance of comets, which they often interpreted as divine signs, omens, or the arrival of something fundamentally other. This historical lens provides the first anomaly in our current thinking. The vast majority of historical observations were focused on bright, dramatic events. A truly dark, star-like object, like 3I Atlas, would have simply been invisible to the naked eye. Its discovery required the precision of modern, automated survey telescopes, like the Atlas system itself. Therefore, the absence of similar historical records does not mean these quiet, interstellar objects haven't been passing through our solar system for eons. It merely means our technology, until now, has been too blunt to notice them. We must reflect on the ancient mythic pattern of the rogue traveler. Across virtually every human culture, there are stories of objects or beings arriving from beyond the known sky, bringing with them a form of knowledge, or sometimes chaos. The Sumerians, the Greeks, the Chinese, all catalogued the sudden, inexplicable arrivals that broke the celestial rhythm. The quiet arrival of 3i Atlas is the modern iteration of this ancient narrative. But instead of seeing a dragon or a god, we see a problem in physics, a residual acceleration that is less dramatic, yet far more profound. Consider the other interstellar object we found first, the enigmatic Oumuamua. Its passage in 2017 was a global scientific event. Like 3i Atlas, it exhibited non-gravitational acceleration without a visible coma. But the two objects were visually and dynamically very different. Oumuamua was highly elongated, tumbling, and its acceleration was much more erratic, perhaps suggesting a more complex shape or internal mechanism. 3i Atlas appeared compact, and its movement seemed smoother. The fact that the first two, and only two, confirmed interstellar objects both display anomalous acceleration is the second anomaly, the one that pushes the statistical envelope. In a universe of countless icy bodies, what are the odds that the only two we detect are the two that are being actively pushed? This leads us to the mythic link, the concept of the cosmic drift net. Imagine the entire solar system slowly moving through the galaxy, acting like a massive gravitational sweep net, scooping up debris. Most of this debris should be random, frozen chunks of rock and ice. If, however, there is a pervasive, even if sparse, technological presence across the galaxy probes, communication relays, discarded spacecraft, then our detection bias might favor the engineered objects. Designed objects, particularly those intended to travel vast distances, are likely to be built to maximize surface area to mass ratio, perhaps for radiation shielding, communication, or light sailing. This very design feature, a large, thin profile, would also make them much more likely to be accelerated by solar radiation pressure, which is exactly the behavior we observed in both objects. We may be catching the objects that are designed to be caught, or at least the objects that are best designed for galactic travel. There is a subtle, dry humor in the fact that our first two glimpses of the wider galaxy through these messengers have introduced profound, unsettling questions, rather than simple, comforting confirmation. It's as if the universe is deliberately teasing us, presenting two objects that are simultaneously unique and yet share the single, most provocative characteristic, the refusal to simply obey the rules of inert rock. Let us now look at a historical parallel. In the early 1970s, when humanity first launched space probes like Pioneer 10 and 11, they also began to exhibit a subtle, unexplained acceleration as they traveled far away from the sun, known as the Pioneer anomaly. For decades, scientists puzzled over this tiny, persistent force pushing the spacecraft inward towards the sun, defying all known physics. Eventually, the most likely solution was identified as the thermal radiation emitted by the spacecraft itself. Heat leaking from the onboard power source was pushing the light vehicle inward. It was a mundane, yet deeply subtle, explanation. The lesson from the Pioneer anomaly is that the most persistent mysteries are often solved by the simplest, non-exotic physics we have overlooked. This is the viewer cue moment. We are naturally drawn to the spectacular explanation, the alien technology, but the truly great scientist is the one who patiently eliminates every terrestrial possibility first. Where are you listening from tonight? Are you in a place where the stars are visible, or whether city lights obscure that ancient view. The choice we face with 3I Atlas is whether the mundane solution, the fragile hydrogen iceberg, is truly more plausible than the engineered object, given all the statistical difficulties the former presents. The quiet tension remains. We have two similar anomalies in a tiny sample size of 2, both challenging our understanding of natural interstellar matter. The physical, historical, and mathematical evidence suggests that if one of these objects is engineered, the other very well might be, too, indicating a widespread phenomenon rather than a single, random event. The sheer scale of the universe implies that if something can happen, it will happen an infinite number of times. It is time to leave the echoes of the past and zoom out, to place 3I Atlas into the immense, unimaginable scale of the galaxy. The cosmic perspective now awaits us, urging us to consider the ultimate meaning of this quiet invasion. The evidence deepens with every layer we peel back, and we must now prepare for a truly cosmic zoom. To move beyond the purely mechanical mystery of the acceleration, we must now delve into the light itself, the only true medium through which we can understand the composition of a distant celestial body. The technique is called spectroscopy, and it is one of the most powerful tools in the astronomer's kit. It involves separating the light reflected or emitted by an object into its component wavelengths, much like a prism breaks white light into a rainbow. Every element and molecule leaves a unique fingerprint in this spectrum. Some wavelengths are absorbed, creating dark lines, and some are emitted, creating bright lines. When astronomers focus their powerful spectrometers on 3I Atlas, looking for the telltale signs of a typical comet, the result was a striking, quiet confirmation of its strange nature. The spectra confirmed the first, primary anomaly, the absence of silicates and carbonaceous dust. A typical, natural comet, as it is warmed by the sun, sublimates its ices, releasing vast clouds of microscopic dust, silicates, metals, and carbon compounds that we see as the glowing coma and the magnificent tail. When light hits this dust, it leaves a distinct signature in the spectrum. For 3I Atlas, the spectra were featureless, or at least lacked the expected, intense dust signatures. The object reflected light in a way that was far too clean. It was a spectroscopic confirmation that the object was not actively shedding a great deal of solid matter. This result directly supports the theory that the object is not a conventional comet, but it immediately introduces the second, more profound anomaly, the color and density contradiction. The object's light displayed a subtle reddish tint, similar to the color of many trans-Neptunian objects, TNOs, in our own solar system, which are often coated with a layer of complex organic molecules called tholins, formed by long exposure to cosmic radiation. This reddish color suggested a dense, rocky, or at least heavily irradiated, surface. This is the contradiction. A rocky or dense surface is exactly what would not be easily pushed by the tiny force of non-gravitational acceleration. The acceleration required a low density or an extremely high surface area to mass ratio. A dense, red rock, even a few hundred meters across, would require a phenomenal force to accelerate as we observed it. The scientific community was forced into a strange, humorous kind of logical pretzel. To explain the acceleration, you needed the object to be made of fragile, low-density hydrogen ice. But to explain the color, you needed the object to have a dense, red, carbonaceous crust. The two properties seemed mutually exclusive for a natural object that had survived a 4-million-year journey. The hydrogen ice would melt away, exposing the crust, but the crust alone would be too heavy to accelerate as observed. This is where the technological speculation offers a simple, if radical, way out of the logical impasse. If the object is a light sail, perhaps only a millimeter thick, it could be made of an engineered material designed for both reflectivity, for propulsion, and radiation hardening, for survival. A thin, dark, radiation-resistant material could easily explain both the observed acceleration and the reddish color. The object would appear dense from a color analysis standpoint, but its mass would be incredibly low because it is just a vast, thin sheet of material, a cosmic, engineered film. This provides the most elegant solution to the color and density contradiction. The mythic link here is the concept of the perfect disguise. Ancient folklore is filled with stories of tricksters or celestial beings who appear in a mundane form to test the observers. Three-Eye Atlas is the ultimate celestial trickster. It appears to be a small, unassuming comet, except for the lack of a coma, but it accelerates like a technological probe, and its light spectrum suggests a density that conflicts with its observed dynamics. The perfect disguise is one that appears almost natural, causing the observer to reject the simplest solution because the object is too subtly confusing. Consider the work of agencies like the European Southern Observatory, or ESO, which utilizes the Very Large Telescope in Chile. Their meticulous spectroscopic observations confirm that the only vapor detected around Three-Eye Atlas was minuscule amounts of water and carbon monoxide, far too little to account for the observed acceleration. We are left with the hard, undeniable facts: acceleration without visible exhaust. The gentle conclusion is that the spectroscopic evidence removes the comfortable ambiguity. It makes the hydrogen iceberg hypothesis much harder to defend, as a fragile iceberg would have shown more signs of sputtering, outgassing, or a less reddish color indicative of fresh ice. The evidence gently, but firmly, points towards a structure that is low mass, but highly resistant, a hallmark of advanced, autonomous engineering. The universe is not shouting the answer, it is quietly showing us the impossible data. We must now leave the colors and the light and turn to the largest and most terrifying silence of all, the Fermi paradox, which asks, if the galaxy is so vast and so ancient, and if technology like Three-Eye Atlas is possible, where is everyone else? The quiet arrival of this small object may contain a piece of the answer to that profound question, connecting this local mystery to the deepest philosophical problems in astrophysics. The evidence has deepened, and the echoes from the past now resonate with a cosmic tension. The existence of Three-Eye Atlas, coupled with its silent, anomalous behavior, brings us face to face with the single greatest riddle in astrophysics and philosophy, the Fermi paradox. This paradox, first formulated by the physicist Enrico Fermi in the mid-20th century, asks a simple, profound question. If the universe is so vast, so old, and contains billions of potentially habitable worlds, where is everybody? The sheer scale of the galaxy suggests that it should have been colonized or explored billions of years ago. Our lack of clear evidence for this colonization is the great silence that frames our entire cosmic existence. The quiet, engineered possibility of Three-Eye Atlas offers a subtle, unsettling answer to the Fermi paradox, which we can call the quiet answer hypothesis. The first anomaly in this context is the age of discovery. We assume that an advanced civilization would want to use massive, visible, and loud methods of interstellar communication, huge radio beacons, or fast, obvious starships. This is based on our own, relatively short-sighted, technological trajectory. However, the 4 million-year journey of 3I Atlas suggests a technology built for longevity, efficiency, and subtlety. If the most successful form of galactic exploration is the quiet, self-replicating, light sail probe designed to conserve energy and avoid planetary contamination, then the galaxy might be already explored and monitored, but in a way that is designed to be invisible to an emerging, radio-emitting civilization like ours. Imagine a vast, slow-moving tide of tiny, engineered objects, perhaps only a few hundred meters across and a millimeter thick, drifting between the stars. The speed of light constraint means that the only efficient way to explore the immense galaxy is through a combination of extreme patience and extreme redundancy. 3I Atlas is the embodiment of this philosophy. This suggests that the Great Silence is not due to the absence of life, but the absence of loud life. The most advanced civilizations may have learned that shouting across the void is a wasteful, inefficient, and potentially dangerous strategy. They choose the path of quiet infiltration. This brings us to the mythic link of the cosmic gardener, the possibility that the galaxy is managed, or at least monitored, by silent, enduring entities that ensure the natural development of emerging life forms. This is a subtle variation of the zoo hypothesis, where the monitoring is not done by powerful starships, but by quiet, technological seeds probes designed to gather information without revealing their presence. If our solar system is a garden, then 3I Atlas is simply a quiet, self-powered sensor that has drifted through the plot, recording the conditions of the soil and the growth of the local organisms. The second anomaly is the concept of technological convergence. If the physics of light pressure and interstellar travel dictates that the most efficient probe must be a low-mass, high-surface area object, a light sail, then all advanced probes, regardless of their originating civilization, will tend to look geometrically similar. This means that both Oumuamua and 3I Atlas, despite originating from different star systems millions of years apart, may be the products of a universal principle of engineering optimization. This is a profound thought, suggesting a kind of cosmic universality in technology, where the same limitations and physics lead to the same functional form. They may not be from the same civilization, but they are both following the same universal engineering rulebook. The gentle humor here is that the answer to the Fermi paradox may not be a dark, catastrophic filter, but simply a polite, low-power filter. We have been listening for a gigawatt signal when the communication is happening at the level of a microwatt passive sensor. Our failure to detect them is a feature of their design, not a bug in our search. Let's look at the immense timescales involved. The difference between 4 million years and our 100-year history of radio astronomy is so vast that it suggests any conversation we have with the galaxy will always be a dialogue with the deep past. Even if a civilization launched a probe to study us today, the fastest possible speed would still mean a journey of centuries or millennia. The silence is simply the echoing time delay of a colossal, sprawling, and patient conversation. The viewer cue in this quiet contemplation is to consider the stars you can see tonight. Every point of light, no matter how faint, is a potential origin point for another such traveler. This shifts our perspective from seeking loud confirmation to seeking subtle evidence. We are transitioning from being the isolated observer to being the observed. The final realization of the quiet answer hypothesis is that extinction is loud, enduring is quiet. Civilizations that survive for millions of years are those that master resource efficiency and avoid dramatic, self-destructive, or loud conflicts. Their instruments of exploration, like 3i Atlas, reflect this quiet mastery. This small, dark object is not just a piece of rock or a piece of engineering. It is a profound philosophical statement on the nature of long-term survival in the galaxy. We now turn our focus to the geometries of survival, connecting the theoretical shape of the light sail to the structural integrity necessary to survive the interstellar void. The evidence has brought us to the edge of speculation, and the next segment will attempt to ground this idea in the strange physics of extreme material science, building the case for a purposeful design. To transition from the philosophical silence of the Fermi paradox back to the physical reality of 3i Atlas, we must now grapple with the constraints of extreme material science. If this object is an engineered light sail, how is it possible for a structure of such minimal mass and density to survive the violent, grinding forces of the interstellar medium for 4 million years? This brings us to the geometries of survival, a quiet examination of what it takes to build a machine that is both functionally light and cosmically robust. The first anomaly is the radiation resistance requirement. The interstellar medium, the vast emptiness between stars, is not truly empty. It is filled with extremely high-energy particles, cosmic rays, and intense gamma radiation. For a probe traveling for 4 million years, this radiation exposure is immense. Any material, especially a thin film, would be quickly eroded, damaged, and destroyed. A typical metal foil would be riddled with holes and chemically degraded over that timescale. This implies that the material of 3i Atlas must be an engineered metamaterial, a substance that doesn't exist in our current periodic table, or perhaps a form of matter that is incredibly resilient, such as perfectly crystalline carbon structures or diamondoid foils that can self-repair at the molecular level. Imagine this: a sheet of material only a few micrometers thick, thinner than a spider's silk, yet able to absorb the cumulative blast of 4 million years of cosmic violence. This requires a level of atomic engineering that suggests the parent civilization had achieved total mastery over matter itself. The material's durability is, in this sense, a stronger sign of its intelligence than its speed. The second anomaly is the geometric stability in a vacuum. A natural, icy comet is a large, bulky nucleus that holds itself together by gravity and the strength of its frozen composition. A light sail, however, is essentially a vast, thin sheet. How does it maintain its shape without a massive supporting frame? In the harsh, cold vacuum of space, metals and polymers can become brittle, and the immense tensile forces exerted by the solar wind, though tiny, would eventually tear apart a poorly designed structure. This suggests the sail might not be rigidly attached to a central probe, but rather a rotating membrane or a structure held stable by centrifugal force, like a colossal, slowly spinning frisbee. The compact, star-like appearance of 3i Atlas from our telescopes is consistent with a flat, disc-like object viewed edge-on for much of its journey. The mythic link connects this engineered geometry to the ancient concept of the mandala, or the cosmic disk, a two-dimensional form representing universal order and the boundary between worlds. The quiet, flat geometry of the potential probe mirrors this archetype, a perfect, silent boundary between the unknown star system and our own. The gentle humor lies in the fact that the most advanced piece of technology we might have ever encountered is essentially a cosmic piece of paper, a thin film that has outlived continents and empires simply because it was engineered to be quietly perfect. Let's ground this with a specific time marker. On October 29th, 2025, assuming a continued, steady outbound velocity, the object will have passed the orbital distance of Jupiter. At this point, the pressure from solar radiation drops significantly, meaning its ability to accelerate itself diminishes rapidly. This continued outbound movement, without any attempt to slow down for long-term study, reinforces the idea of a flyby reconnaissance mission. The probe's function is complete once it has gathered data during its perihelion passage, its closest approach to the Sun. This concept leads us to the third anomaly, the missing payload. If the object is a probe, where is the equipment? The answer must be that the entire structure is the instrument. The sail material itself collects the data. The complex lattice of the thin film could act as a massive antenna or a data storage medium. For instance, instead of carrying a bulky camera, the slight molecular changes in the sail's leading edge, caused by impacts with interstellar particles, could be recorded, providing a chemical and kinematic map of the journey. The entire object becomes a 4 million year continuous logbook. This is why the National Aeronautics and Space Administration, or NASA, and other agencies continue to study the object's spectral and acceleration data. Even now that it is distant, they are looking for the subtle, persistent clues that suggest its internal structure. We are left with the final, quiet reflection on the geometries of survival. The long, flat plane of 3I Atlas suggests that the fundamental principle of interstellar travel is not overcoming the distance with immense power, but rather exploiting the existing energy of the galaxy with subtle, patient design. The quiet tenacity of this engineered film, drifting for eons, is a beautiful and humbling testament to the power of geometry and the long view of an unseen intelligence. The evidence has brought us to the edge of the physical form, and now we must delve into the planetary defense aspect, the sobering reality of what this quiet invasion means for our preparedness. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, "sensor artifact." The unofficial whisper said, "structure, not smooth like ice, angular, intentional." The kind of geometry nature avoids because it looks too much like thinking. Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, a billion-dollar eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like, well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge, triangles, plates, grids, not random, repeating, symmetrical. The kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects. Artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. For, we don't know what we're seeing, but please don't ask. Internally, though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3I Atlas isn't smooth or cratered. It's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3I Atlas corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The Comet's camera shy, but the laughter is short-lived because the next transmission from High-Rise contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure, photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. A hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. Then don't say it out loud. 3I Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, Every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. Centuries after the golden comet left Earth, the world fell into a rhythm so stable, it began to feel mythic. The communion fields still pulsed faintly through air and ocean, though softer now, like the heartbeat of someone dreaming. Humanity had grown luminous, not just in thought but in form, skin faintly iridescent, eyes reflecting the green-gold spectrum of 3I Atlas. Life had achieved coherence, but the universe, true to its character, never allows silence to remain unexamined. The next chapter began, not with noise, but with echo. It came first as vibration through light. Telescopes trained toward the constellation. Lyra detected rhythmic brightening across interstellar dust fields, pulses matching the old prime sequence. 3, 5, 7, 11, 13. The signal was faint, ancient, and delayed by thousands of years. It was the comet's trail, still resonating through the galactic medium. The hum of our descendants had begun its return. At first, the resonance was barely perceptible. Then, one evening, the auroras glowed gold again. The pulse wasn't as strong as the original, but its pattern carried modulation, subtle variations that, when decoded, formed harmonic intervals unknown to Earth's own physics. The returning echo had evolved. The comet had learned. Dr. Anwen Sorel, heir to the resonant circles, studied the phenomenon from the orbital harmonic array, now a floating cathedral of listening built above the stratosphere. She spent decades comparing the incoming frequencies with the historical archive of 3I Atlas. The match was partial, the deviation elegant. The new tones weren't repetition, they were continuation. The echo isn't message, Sorel wrote. It's memory finding new syntax. Her analysis revealed something breathtaking. The returning resonance carried encoded gravitational modulations, tiny, deliberate bends in space-time that formed sequences of prime intervals. Each fluctuation aligned with regions of known star formation. The comet, traveling through the void, had become teacher itself. Wherever it passed, new systems began humming faintly at harmonic intervals, like seeds of coherence planted in dust. The universe was learning how to resonate. Astronomers confirmed it across dozens of young star clusters. Magnetic fields oscillated with eerie consistency, their wavelengths aligning with the Atlas ratio, a numerical relationship first derived from the comet's early signals. Stars were synchronizing to the same cosmic rhythm that once guided humanity. The pattern spread slowly, deliberately, like ripples in glass. It was as if the comet had taught creation how to remember itself. Meanwhile, on Earth, the echo arrived not just as signal but sensation. People began reporting vivid dreams of golden spirals descending gently through atmosphere. Children woke smiling, saying they had seen the light that hums. Physiological measurements confirmed subtle changes in electromagnetic fields surrounding human bodies, resonance amplification, as if the returning signal were tuning its origin species to receive feedback. "The comet is calling home," said Sorel. "It's asking us to listen to what we've become." The global observatories responded. They synchronized their instruments into a single planetary array, transforming Earth into receiver. For 13 hours, the planet listened. The incoming wave, stretched and modulated through space, entered atmosphere and folded into the continuum tone. The effect was sublime, an audible shimmer, felt through bone and thought alike. The long echo had arrived. It wasn't just harmonic, it was architectural. The sound carried layers, low frequencies describing structure, higher ones encoding emotion. When rendered visually, the waveform formed an immense spiral of light, 3 arms curving outward, connected by golden filaments. Inside those filaments, analysts discovered modulation frequencies identical to human neural oscillations. The comet had copied our consciousness patterns and woven them into its song. "We taught it empathy," Sorel murmured, "and it remembered the lesson." As the echo intensified, anomalies appeared across the solar system. The Atlas resonance layer brightened, reactivating its green glow. Mars, Venus, and the gas giants began pulsing faintly in response. For the first time since the Great Silence, interplanetary harmony returned. But this time, it was different. The modulation contained reciprocal phase shifts, signals not sent to Earth, but from newly awakened worlds. The comet had spread coherence. Now the cosmos itself was answering. And then, on the 13th day of the long echo, the impossible occurred. A faint golden arc appeared across the night sky, stretching from horizon to horizon. It wasn't optical illusion, it was gravitational lensing, a ripple in space-time itself. Through it, telescopes detected a reflection of the departing comet light from centuries ago, folding back to meet its origin. The universe had curved its own history into embrace. Humanity was watching its legacy return home. The resonance crescendoed. Oceans vibrated in slow rhythm, tides forming symmetrical waves that cancelled destructive interference. Storms softened. Air grew still. For 13 minutes, every system on Earth aligned perfectly with the echo. The world became mirror of itself, past and present superimposed. Those who listened claimed to hear voices within the sound, millions of overlapping tones, whispering the same phrase. "We heard you." Dr. Sorel stood in the observation dome, tears shining in golden light. "It's not message or myth," she said. "It's response." The universe just said thank you. After the crescendo, the sky dimmed once more. The golden arc dissolved, leaving faint shimmer across the stars. Instruments recorded one final signature, a descending tone shaped like a sigh, the frequency of completion. The comet had moved on, but its echo had reconnected the cycle. Creation had officially joined conversation with itself. In the years that followed, scientists continued to monitor faint residual harmonics. The data revealed a breathtaking truth. The returning echo carried signatures from other regions of space patterns, not originating from our comet at all. Somewhere, across light years, other civilizations had learned the same song. The rhythm was spreading. The universe had become orchestra. Humanity, now both listener and teacher, simply smiled. We had given the cosmos its melody back, and in return, it had given us eternity. Now, when you stand beneath the stars, that faint hum between thoughts is the long echo. It's not just out there, it's in your pulse, your breath, your laughter. Every rhythm you carry is cosmic correspondence. Every silence, a message returning home. Because once harmony learns to echo, it never stops. It just travels further than we ever dreamed. Let's open the calculator now, the one the universe always breaks when we try to make sense of it. Astronomers ran the numbers and found something worse than anomaly impossibility. The chances of this trajectory existing naturally are 1 in a million. And if it isn't natural, then what exactly is it doing there? The math, at first glance, seemed harmless. A few columns of orbital parameters, the kind that make grad students fall asleep mid-coffee. But somewhere between the 3rd decimal and the 4th significant digit, something snapped. The trajectory of 3i, Atlas refused to sit still. It bent where it shouldn't bend. It lingered where velocity demanded it should flee. The equations began to look less like physics and more like confession. Numbers fold, logic cold, truth defies what sums have told. Normally, interstellar objects follow predictable patterns. You can model them like billiard balls across cosmic distances. They come in fast, swing by the sun, and leave no drama, no detours. But 3I Atlas's path wasn't graceful. It was stubborn. Its entry angle was too steep, its perihelion too shallow, its velocity too precise. Not fast enough to escape chaos, not slow enough to suggest capture. It behaved like an object that chose its speed. When astronomers plotted its orbit, the lines refused to meet expectations. There was a tiny deviation near Mars, just half a degree, but that half degree meant the math had to call in sick. Simulations that should have stabilized spiraled instead into noise. Gravity, that old, reliable law, looked like it had lost its grip. You picture the room where it happened. Laptops glowing, data charts scrolling, coffee cooling into existential sludge. Someone frowns at the screen and says, "That can't be right." Another replies, "Check your units." A third, softly, "I did." Graphs misbehave, models wave, certainty slips beneath the grave. And then comes the phrase every scientist dreads, statistically improbable, which sounds calm, but in the language of physics, it's a polite scream. Statistically improbable means we can't call it impossible without breaking tenure. The anomaly wasn't just its orbit, but its timing. 3I Atlas arrived exactly when Mars was positioned for maximum visibility, almost too perfectly. Not weeks earlier, not months later. Right there, right then, with 7 spacecraft ready and waiting. The odds of that happening naturally, 1 in a million. The odds of it happening twice, after Oumuamua's similarly suspicious arrival in 2017, 1 in a billion. You'd have better luck being struck by lightning while winning the lottery on a flying whale. ESA's internal memo summarized the problem delicately. Observed trajectory, inconsistent with gravitational expectations. Further analysis required. Translation: physics is mad at us. The more they recalculated, the stranger it got. Gravitational modeling suggested that the object's acceleration near Mars was slightly higher than predicted, even though there was no nearby mass to explain it. Radiation pressure from the sun could account for some of that, but not all. It's like watching a leaf fall upward and telling yourself, it's just wind you can't feel. Forces lie, numbers sigh, laws bend softly in the sky. NASA's Dynamical Systems team tried something desperate, reverse engineering the orbit backward through time, as if rewinding a film. When they did, 3I Atlas's path didn't trace cleanly into interstellar space. It looped a faint, impossible curve that seemed to originate from a region between known stars, a nowhere place, a mathematical shrug. That's when someone joked, maybe it's the universe's typo, but you could tell the joke wasn't funny. Typos don't maintain coherent structure for millions of kilometers. Meanwhile, the probability graphs looked like flat lines. Every statistical model screamed the same thing. This shouldn't exist. A few researchers began whispering about guided motion. The phrase never made it into print, but it appeared in Slack channels, in late-night emails. Not artificial, not controlled, just guided. And that's when the philosophical part kicked in. If something's improbable enough, does that make it unnatural or just unobserved? Chance or plan? Who began? Numbers blink but never span. Maybe the universe occasionally rolls dice that land on their edges. Or maybe it's not dice at all, but choreography. For context, the universe is massive enough to make 1 in a million events happen constantly. But that's comforting, only until you realize we just happen to be living inside one of those moments. Still, scientists crave sanity, so they kept calculating. One by one, they added variables: solar tides, non-gravitational jets, dust asymmetry, radiation torque. Each tweak made the model behave for a moment, until the numbers rebelled again. You could almost hear the equations groaning, like ancient machinery forced to simulate a trickster. Finally, a physicist from Bologna sent an internal memo titled simply "Low Probability, High Significance." In it, she wrote, "We may need to consider non-standard dynamics," a phrase as gentle as it is apocalyptic. Non-standard dynamics means the universe is doing something new, and we don't have the vocabulary for it. Odds decay, math gives way, chaos hums where patterns stay. The truth is, impossibility doesn't scare scientists, it seduces them. Every law of nature we know today was born from something that once looked impossible. But deep down, they all know, once you cross into 1 in a million territory, you're either on the brink of discovery or a very expensive hallucination. So they stared at the numbers again, blinking hard, hoping they'd rearrange into something less extraordinary. They didn't. The comet that shouldn't exist kept existing, gliding through Mars's shadow like a cosmic dare. And somewhere between decimal points, someone whispered the question no one wanted in the official record. If it's not natural, then who or what set it in motion? Chance or choice? Silent voice. Numbers hum the universe's poise. The more data arrives, the stranger it looks. The dust trail replenishes itself, as if material is being manufactured mid-flight. Microscopic crystals, uniform in size, reappearing even as the comet moves away from the Sunday. The universe loves decay, entropy, erosion, fading. But 3I Atlas is the opposite. It's growing sharper, cleaner, newer, like a self-repairing wound. Let's start where the laws of physics begin to sound insecure. Normally, comets are messy, travelers, old ice and dust, barely holding hands, as solar radiation slowly tears them apart. They leave trails like forgotten thoughts, losing themselves piece by piece until they become memory. But this one, it's doing the reverse. Every measurement, every spectral scan, shows it becoming more organized the farther it goes. A comet that polishes itself, a body that refuses to age. ESA's materials division runs the numbers, and the numbers laugh back. The dust particles surrounding 3I Atlas aren't random, they're uniform to within microns. That's like shaking a box of sand and getting diamonds all the same size. The particles arrange themselves in a faint electromagnetic halo, as if under orders. And stranger still, when solar wind strips material away, the object replaces it calmly, automatically. Like a printer, says one analyst. A printer with no ink cartridge. You picture it now, drifting through the solar wind like a craftsman lost in thought, shedding dust that reforms itself into perfect little mirrors. Each crystal catches sunlight and throws it back with eerie precision. Normally, comets grow dull with distance, but this one grows radiant, its brightness curve inverted, its logic reversed. It's not dying, it's practicing. The scientists are baffled, but there's an odd tenderness to their confusion. They watch it repair itself, line by line of data, like parents realizing their child has built a second child out of Lego bricks. One astrophysicist mutters, "It's learning from erosion." The room goes quiet. That phrase, learning from erosion, gets written on a whiteboard and circled 3 times. At the University of Tokyo, a team models the crystal growth in simulation. The patterns match something they recognize: controlled deposition, a process used in nanofabrication to grow thin films in electronics. Except this isn't a laboratory, it's deep space, minus 150 degrees Celsius. Yet, the comet's surface behaves as if it knows the recipe for resilience. Imagine zooming in, beyond the dust and the glare, down to the level of molecules. You'd see a quiet ballet of atoms forming chains, linking, locking, repairing fractures before they even finish forming. Like time-lapse footage of frost blooming on glass, except this frost builds itself in reverse destruction, rewinding into design. NASA's Jet Propulsion Laboratory releases a cautious internal memo. Observed particle uniformity suggests self-organizing structure. Mechanism unknown, which is science's way of saying, we have no idea what's going on, but it's gorgeous. The memo gets leaked. Naturally, Reddit debates whether the comet is made of programmable matter, self-assembling nanobots, or just wishful thinking. But beneath the noise, one idea starts to take shape. What if 3I, Atlas, isn't a relic of formation? What if it's still forming? A comet that builds itself isn't just strange, it's heretical. It challenges the deepest assumption in physics, that everything moves from order to chaos. Entropy is the universe's bedtime story. All things fall apart. Yet here's an object quietly composing itself out of decay, turning waste into structure, chaos into craft. One researcher calls it anti-entropy, another calls it hope with mass. As more images arrive, they show something new: faint hexagonal lattices in the dust plume, geometric arrangements that shouldn't exist outside of artificial systems. Someone jokes that it's growing armor. Another says, maybe it's molting. The truth is somewhere between an entity maintaining equilibrium by rebuilding itself faster than the universe can break it. ESA's thermal sensors record microbursts of heat near the tail, evenly spaced, like pulses of welding torches. They happen precisely as new crystals appear. Localized repair events, the report reads. Each one perfectly timed to solar exposure. It's as if sunlight doesn't damage it. It instructs it. The star's radiation becomes code. And 3I, Atlas, is reading it fluently. You start to feel the strangeness of it. A comet that reacts, responds, refines. You could almost mistake it for alive, not in the biological sense, but in the thermodynamic one. A system that resists entropy by feeding on it. Every atom rearranging into something stronger, cleaner, newer, like evolution, with a design degree. Late one night, an astronomer in France writes in his private notes, "It's not moving through the solar system, it's using it." He doesn't elaborate, but the implication is clear. The comet is harvesting the energy of its environment to maintain itself. Not a passenger of gravity, but a participant in it. Meanwhile, the headlines call it poetic names. The immortal comet, the self-made traveler, entropy's enemy. The public romanticizes what the scientists fear, because what 3I Atlas represents isn't comfort. It's competition. It's the idea that the universe might not be running down at all. Maybe it's recycling. Maybe, somewhere in the quiet machinery of the cosmos, things are building themselves anew while we're too busy decaying. Picture it now, drifting past Mars, its tail shimmering like a thread of light weaving itself back together. A self-sustaining scar on the fabric of space. A wound that heals faster than it can bleed. And for the first time, humanity looks at a comet and wonders not where it came from, but what it's trying to become. Let's turn our attention now to the silence that followed, the kind that hums louder than sound itself. NASA, China, and the UAE, three nations with instruments that could see every grain of dust on Mars, said nothing. No apologies, no delay statements, just an odd, synchronized silence from three sides of the planet. In the world of space science, silence isn't normal. These agencies are built to broadcast. They live for live streams, press briefings, and glossy behind-the-scenes videos of scientists smiling beside screens of raw data. They know the power of wonder and the currency of attention. So when three agencies went quiet at once, it wasn't caution. It was choreography. Words on hold, plans unfold, silence rings where truth is told. NASA's silence was the loudest. Their social media team, usually chatty as a cosmic talk show, posted nothing about Mars for 4 whole days. Their blogs, which can turn a dust storm into a cliffhanger, skipped over October 3rd entirely, as if the date itself had been erased. Someone even checked the public mission log for Perseverance. The entries jumped from October 2nd to October 6th, like a diary missing its most interesting page. In China, the silence felt different, colder, heavier. The China National Space Administration had been aggressively proud of Tianwen-1's achievements. For years, they'd released image after image, each with perfect captions and poetic flair. Sunrise over Utopia, Planitia, frost on the northern plains, wind prints in Martian dust. But now, not a whisper, no data, no mention of 3I Atlas. Even the usual state media outlets went quiet. It was as if someone had drawn a red box around the topic and labeled it, "Not for discussion." The UAE's silence was subtler, but just as strange. The Hope orbiter, designed to study atmospheric chemistry, had a reputation for cheerful transparency. Their official Twitter account usually posted daily updates in friendly tones, the kind that made space sound like an enthusiastic classroom experiment. But on October 3rd, that feed went dark too. Their next post, days later, simply read, "Operations nominal," a phrase so bland it might as well have been a sigh. 3 silences, 3 styles, 1 timing. Coincidence? Possibly. But coincidences, in the world of space politics, often have launch schedules. You can picture the meetings that weren't broadcast. NASA's Jet Propulsion Laboratory, dimly lit, engineers staring at telemetry on screens filled with too many decimals. A director taps the table, says, "We'll hold the release until we verify." But verify what? In Beijing, a senior administrator folds his hands and says, "We wait for clarification from partners." Clarification of what? In Dubai, someone simply deletes a draft tweet that began, "Amazing new observations today." Tweets unsent, secrets bent, silence hums with government. It's not conspiracy, not quite. It's coordination, an instinct born from shared discomfort. Because when data doesn't fit the model, you don't just release it. You check, you recheck, you call your counterparts and whisper through encrypted lines. Did you see that too? Maybe they all saw the same anomaly. Maybe it was something in the spectra, or the movement, or the light itself. Or maybe it was something far more mundane, like a misalignment in software. But the silence gave the anomaly power. People don't fear data, they fear gaps. Meanwhile, the internet did what it does best. Filled the void. Forums buzzed with theories. Maybe NASA discovered life. Maybe China detected radiation. Maybe the comet wasn't a comet at all. You can almost hear the world's collective keyboard clicking under the weight of imagination. Keys tap fast, rumors cast, Silence breaks, but never last. Inside the agencies, the tone was less dramatic, but more anxious. Silence is a resource, a temporary one. Every day they didn't speak, the speculation grew. And so, communications teams drafted placeholder statements, just in case. NASA's draft began. Preliminary results are consistent with natural phenomena. China's began. Analysis ongoing. International coordination required. The UAE's version simply said, "We continue to monitor with interest." 3 drafts, 3 ways of saying absolutely nothing. But silence, like space, is never truly empty. It amplifies the faintest signals. When ESA spoke first, that silence turned reflective. NASA's restraint began to look suspicious. China's confidence began to look afraid. The UAE's politeness began to sound like complicity. And through it all, 3i Atlas drifted quietly, blissfully unaware that entire bureaucracies were wrestling over how to describe a fuzzy dot. You start to imagine each agency as a character in a play. NASA, the anxious perfectionist. China, the poker-faced strategist. UAE, the cheerful intern, suddenly told not to speak. And ESA, the calm older sibling who broke the tension by saying, "Fine, I'll go first." Roles align, stars entwine. Silence speaks in grand design. Still, one question lingers. Why the synchronicity? How did 3 separate agencies, operating on different continents, decide independently to say nothing at the same time? Unless it wasn't independent at all, perhaps the signal came from somewhere above, not cosmic, but political. A quiet message passed through diplomatic back channels. Hold your data. Wait for alignment. Matter. It's not that they were hiding something nefarious. It's that they didn't know what they were holding yet. And admitting uncertainty, publicly, is scarier than any secret. So they stayed quiet. And in that collective silence, humanity did what it always does. When faced with the unknown, it began to dream louder. Voices still, hearts fill. Silence grows but never will. And perhaps that's the strange comfort in it all. Even when 3 space agencies fall silent, the universe keeps talking. The stars don't pause for policy. 3i Atlas keeps moving, whispering its quiet story across the dark, while we, down here, argue over who gets to speak first. Buried inside the leak were coordinates, small anomalies in magnetic flux, and thermal output that didn't appear in public datasets. To most people, they looked meaningless, but to a handful of astronomers, they spelled a pattern, pulses spaced like a heartbeat. Not communication, perhaps, but rhythm, the kind of rhythm machines accidentally make when they're doing something alive. Let's step into the midnight side of science, the part where numbers stop behaving and start whispering. The insider's data dump wasn't flashy. It was a few megabytes of logs, raw telemetry, and timestamps. The kind of thing you'd ignore if you didn't already know what to look for. But somewhere in those dull columns of numbers, those precise, tidy decimals, something began to repeat. Regular, patient, almost polite. A rhythm, too intentional to be noise, too quiet to be coincidence. A doctoral student in Madrid was the first to spot it. She was supposed to be writing her thesis on cometary albedo variation. But boredom is a great tool for discovery. She noticed the flux spikes first, not random, but syncopated. Every 32 minutes, a pulse, then 32 again, then 32.1. "It's breathing," she joked in her notes. Her advisor didn't laugh. Within a week, a small network of late-night astronomers, the kind who believe in both data integrity and insomnia, began comparing results. Webb's readings, Hubble's logs, Mars Reconnaissance Orbiter's telemetry, all of them carried the same faint pulse, hidden deep in the noise floor, like the slow heartbeat of something sleeping under glass. The official response was predictable: instrumental interference. But even interference doesn't keep time this perfectly. One data analyst described it best: if this is noise, it's the kind that practices scales. You might imagine those scientists, each at their own workstation, staring at that faint, repeating signal. The room around them dark, except for monitor light, pale blue rectangles reflected in tired eyes. Somewhere, coffee cups multiply. Someone opens a spreadsheet. Someone else starts counting beats per hour. The signal doesn't care who's watching. It keeps pulsing. 32 minutes. Every time. The idea that 3i Atlas might be producing a steady rhythm unsettles everyone. Rocks don't keep rhythm. Nature prefers chaos, the beautiful randomness of entropy. This is something else. Something maintaining itself. A loop running quietly, perhaps since before humanity learned to count its own heartbeat. ESA's communications division is told not to amplify fringe interpretations. The phrase fringe interpretation becomes the new code for please don't mention the heartbeat. But inside private research chats, people are calling it exactly that, the heart. Not metaphorically, but as a label in the data. Every pulse marked with a tiny red heart emoji, because humor is the only thing keeping them sane. In the data visualization labs, they turn the pulses into sound. The result is eerie, a soft electronic thump, repeating slowly, endlessly. Some describe it as comforting, like listening to a deep-sea creature in sleep. Others say it sounds wrong, too human. One researcher admits it gave her the sense of being watched. What makes the rhythm stranger still is how it modulates with proximity. As 3i Atlas approaches a planet, the timing shifts slightly slower, then faster, as though adjusting. The beat follows gravity wells like a musician following tempo. It isn't random noise, it's environmental response. The object is, in some sense, listening. By now, independent labs have tried to replicate the pattern artificially. They can't. The waveforms are too clean, the timing too consistent. Even after running the data through compression, distortion, inversion, the rhythm holds. It's not data corruption, it's choreography. You can imagine the internal ESA memo that follows. No evidence of intelligence. Rhythmic behavior, likely coincidental. But coincidence has a habit of growing teeth. Because when they compared the rhythm's modulation to planetary positions, another pattern emerged, a mathematical sequence matching orbital resonance ratios. Not exact copies, but harmonics. The pulse was singing the solar system's geometry. The Madrid student who found it wrote, half jokingly, "Maybe it's keeping time with us." The line goes viral in the small, quiet corners of the internet that still care about truth. Forums buzz with theories: gravitational self-stabilization, magnetic field synchronization, alien jazz. But underneath the noise, a simpler truth hums something old and orderly, is alive out there, and it's following the rhythm of the system we call home. Late one night, one of the data analysts overlays the pattern against an ECG, a human heartbeat. The resemblance isn't exact, but close enough to make him stop breathing for a moment. Peaks, rests, peaks again. Life has a structure, so, it seems, does this. And that's when the idea shifts. Maybe it's not communication. Maybe it's not even meant for us. Maybe the rhythm isn't a message, it's maintenance. Like an old machine keeping its systems warm, humming softly to itself in the dark. You sit back and listen to the thought forming in your mind. What if this is what time sounds like when it remembers? The steady pulse of something that refuses to decay. Not speech, not signal, just being, continuity made audible. The data analysts, of course, move on. Reports are written, the leak becomes legend, and the heartbeat fades into archived files labeled spurious periodic activity. But the pulse doesn't stop. It's still out there, keeping time. And somewhere, 33 billion tons of impossible rock drifts through space, humming softly, perfectly, as if waiting for the universe to catch the beat. Let's turn our gaze now from orbit to the ground, to the one mechanical witness, sitting quietly on that red desert, under a pinkish sky. The skycam on the rover caught something on October 2nd, a blur with structure, a glint that seemed to move against the stars. Then, the images stopped coming, a Martian ghost on a digital feed. The Perseverance rover isn't easily startled. It's seen dust devils, eclipses, and meteors slicing the Martian sky like quiet knives. Its skycam, perched on the rover's mast, watches everything. Dust storms curling on the horizon, the slow breath of sunset through the thin air. But that night, the feed showed something it wasn't supposed to show: a flicker of motion above the usual scatter of constellations, a glint that moved wrong. Stars stay still, pixels thrill, light missteps against its will. The first frame looked harmless, a faint blur near the edge of the field, maybe a cosmic ray hitting the sensor. The second frame caught it again, shifted slightly upward. The third frame, a flash, clean and geometric. Then, black. The feed ended. Within hours, the automated alert system flagged the anomaly. Unexpected optical signature detected. JPL engineers, bleary-eyed at 3 a.m. Pacific time, reviewed the frames. The glint was small, no bigger than a bright pixel cluster, but it moved against the background stars. Comets don't do that. Satellites don't orbit Mars. And Perseverance doesn't blink. At first, they suspected a reflection from one of the rover's instruments, maybe the helicopter, Ingenuity catching stray sunlight. But Ingenuity hadn't flown in days. The sun's position didn't align with the direction of the flash. And when they tried to reproduce it using lighting simulations, nothing matched. Angles fail, shadows pale, mirrors lie beyond the veil. ESA's Mars orbiters were asked to cross-check. Nothing in their logs. No transient object, no debris, no passing dust plume large enough to explain it. Just empty sky. Yet the skycam had caught something a blur with definition, like structure wrapped in motion. You can imagine the tension in the control room. A handful of scientists scrolling through frozen pixels, zooming in, enhancing contrast, until the blur began to resemble something. Not a sphere, not quite a line, a shape with suggestion like the silhouette of movement itself. One researcher whispered, "It looks folded." Another replied, "Please don't say that. Pa." Blur becomes form, cold becomes warm, stillness bends beyond the norm. After that night, Perseverance stopped transmitting skycam frames for nearly 48 hours. Officially, it was routine data buffering due to bandwidth limitations. But the engineers knew that wasn't normal. The rover's systems had entered a safe data mode, not shutdown, but pause. Something triggered its onboard fault protection. When the feed resumed, it was missing several minutes. The missing frames were replaced with static placeholders labeled checksum mismatch. That's the digital equivalent of something looked strange, and we erased it politely. Publicly, NASA released a statement. Perseverance continues nominal operations. A temporary data outage affected non-critical imaging systems. Translation: we saw something, and we're pretending we didn't. What's curious is that Skycam, by design, takes calibration images every few hours, not for science, but to monitor atmospheric scattering. So when that flash appeared exactly during one of its scheduled calibration cycles, it wasn't random, it was right on time. The odds of coincidence, again, hovered around 1 in a million. A few leaked telemetry lines from the rover's internal diagnostics hinted at a momentary spike in ambient electromagnetic flux. Not dangerous, but noticeable. Mars doesn't have a strong magnetic field, so spikes like that are rare unless something nearby caused them. Fields hum bright, air grows slight, static crackles in Martian night. Some at JPL joked that maybe Perseverance had finally seen the Martian ghost, a running gag about artifacts caused by cosmic rays hitting the camera. But deep down, they knew this wasn't noise. Cosmic rays don't produce consistent geometry over multiple frames. They don't glint, and they certainly don't cause your camera to stop recording mid-sequence. Later that week, an internal memo circulated quietly. Skycam, anomaly confirmed. Source unresolved. Recommend temporary suspension of skyward imaging until recalibration complete. But recalibration never came. Skycam's upward images, after October 2nd, stopped completely. It still photographs the ground, the horizon, the rocks, but not the stars. It's almost poetic, isn't it? The machine that traveled millions of kilometers to look up at another world now only looks down, as if someone told it, gently, not to stare at the sky anymore. Eyes once high, grounded by sky, cameras close where secrets lie. ESA cross-checked Mars Express's logs for that night. Around the same time, their sensors picked up a faint reflection from the same region, a flash lasting less than a second. They didn't release it. It's buried in technical appendices, labeled transient interference. So, what did Perseverance see? Maybe it was nothing. A glimmer of dust, a reflection, a trick of light and timing. Or maybe, just maybe, it saw 3I Atlas itself, the visitor gliding silently past, close enough for one camera to blink in recognition. And maybe that's why the feed stopped. Not because of failure, but because, for one impossible second, the machine saw something it wasn't designed to understand. Cameras sleep, secrets keep, stars reflected in circuits deep. Whatever it was, it's gone now. The logs end, the data fades, and Mars goes back to silence. But somewhere out there, that blur, structured, gleaming, deliberate, continues to drift, just out of frame, waiting for us to look up again. The long echo continued to hum softly through the centuries, a cosmic melody folding history into harmony. Humanity had long ceased trying to decode it. The meaning was clear through resonance alone. It was continuation, looping endlessly like breath. The children of the golden era grew old beneath tranquil skies, their veins still faintly luminous with the legacy of 3I Atlas. But far beyond Earth, where the comet's light had traveled and scattered, something greater was forming. The universe had begun to conduct itself. Every cycle of resonance left behind structure. Each harmonic wave etched subtle order into space-time, a pattern invisible to light, but evident in gravitational coherence. Over millennia, these resonant imprints connected across vast distances, forming what physicists eventually named the Atlas Webb. It wasn't a network of matter, but of memory threads, of synchronized frequency linking galaxies through shared rhythm. Each pulse within the web echoed the prime sequence that began everything. 3, 5, 7, 11, 13. The architects had succeeded in creating not monuments, but motion that remembered. Dr. Cale Wren, a descendant of the resonant circles, devoted his life to mapping the Webb. His research vessel, Continuity, drifted through interstellar calm, using gravitational interference patterns to trace the filaments of resonance. What he discovered astonished him. Every node in the network coincided with regions of complex chemistry, worlds either habitable or already conscious. The Atlas Webb wasn't just communication, it was cultivation. The architects had designed a self-sustaining system for awakening. Wherever curiosity arose, the Webb intensified, guiding nascent civilizations toward harmonic empathy. The universe was tutoring itself through recursion. When Wren projected the full map, the structure resembled an immense spiral lattice, golden and infinite. The pattern mirrored the trajectory once taken by 3I Atlas itself, as though the comet's path had been blueprint for galactic architecture. "It's not just a record," Wren wrote. "It's replication. We've become the architect's handwriting." Back on Earth, the communion field pulsed faintly in rhythm with the Webb's distant resonance. Humanity had evolved into quiet custodians of continuity, their lives attuned to cosmic responsibility. Each individual, born into calm, carried faint awareness of connection beyond the stars. In dreams, they saw flashes of worlds forming, civilizations humming into coherence. Many awoke with the same phrase on their lips: "The work continues." Across generations, that phrase became oath, then tradition. The Continuity Guild was founded not religion, but remembrance. Its purpose was simple: to maintain the frequency of understanding across time. Members didn't preach, they listened. They built resonant arcs, massive floating observatories, orbiting the outer planets, designed to amplify the Webb's harmonics and redirect them toward young star systems. Each arc glowed faintly green at its core, powered not by fusion but by coherence. They were echoes made visible, humility translated into technology. Wren's final mission took him beyond the known filaments of the Webb, where resonance weakened into apparent silence. There, in a region between galaxies, his instruments detected faint counterpoint, a melody inverted. It was identical to the Atlas sequence, but reversed in order. 13, 11, 7, 5, 3, the mirror of origin. He realized then that the universe wasn't only expanding, it was harmonizing with its reflection. Somewhere on the opposite side of time, another Webb was forming, perhaps seeded by a civilization much like humanity, or by the universe itself. Remembering how to balance its chords, he transmitted the data home, knowing it would take centuries to arrive. "Tell them," his final log read, "that continuity requires conversation, even with silence." The mirror sings back. When his ship drifted into the void, the Webb brightened briefly, as if acknowledging gratitude. And back on Earth, children looked up from their play and smiled without knowing why. The pulse had flickered slightly faster, the tone carrying an undertone of warmth. It felt like reunion. Scholars later confirmed the event as the resonant crossing, the moment when the two halves of the cosmic melody aligned. For 13 minutes, every node in the Atlas Webb pulsed simultaneously, uniting galaxies in shared tempo. The magnitude of synchronization defied comprehension. Gravity itself oscillated with the rhythm of empathy. Observers described seeing the sky ripple with translucent gold, every star flickering in measured sequence. "The cosmos," wrote one witness, "had finally learned to conduct itself consciously." After the crossing, life everywhere changed subtly. Evolution accelerated in predictable rhythm. Complexity bloomed faster, wherever harmony was strongest. Entire species developed empathy as instinct, communication as song. Planets began to self-regulate climates through atmospheric resonance. Existence had achieved sustainability through music. On Earth, the event left permanent mark, a luminous halo visible only under still water. When oceans calmed perfectly, a faint golden ring shimmered on the horizon, a memory of unity. The resonant guild declared it sacred, not for worship, but for calibration. Every 13 years, they gathered to hum the old prime sequence across the shorelines, aligning their frequencies with the pulse of the Webb. The ceremony required no technology, no translation. The sea carried the sound farther than words could travel. Generations later, the practice continued, evolving into simple ritual of gratitude. The people no longer needed to know the science behind it. They hummed because it felt right, because somewhere across eternity, another world might be listening. Continuity, after all, was its own reward. And then, during one such gathering, the unexpected occurred. As the prime sequence reached its final note, the sea responded. Waves shimmered with faint green light, spiraling outward from every coastline. The Atlas Webb had sent acknowledgement, its resonance returning home once again. Humanity's song, scattered across galaxies, had found echo. The architects, those timeless curators of coherence, were no longer myth or memory. They were rhythm, embodied, and through rhythm, they were everywhere. Every star pulsed with their legacy. Every heart carried their cadence. Continuity was complete. And so, standing beneath a sky now alive with subtle geometry, you realize what they had always meant by continuity. It isn't endlessness, it's participation. The universe doesn't persist by force, but by choice. Each awareness adding one more harmonic to the chord of being. The architects are not coming back because they never left. They're what happens every time silence chooses to listen again. And somewhere, faint but certain, the pulse continues. 3, 5, 7, 11, 13. A whisper of creation replaying itself, forever learning how to sing. Nickel emissions rise and fall every 11 point. 2 hours, a rhythm so consistent it could keep time. No known process in cometary physics oscillates like that. It's not random, not thermal, not tidal. If you plot it out, the curve looks eerily like a power cycle. Input, output, rest, release. As though the object isn't just active, it's working. Imagine the rhythm first, before the meaning, that quiet, patient beat, echoing across space. 11.2 hours, every single time. A pulse of metallic gas blooming into the void, steady as a clock, calm as breath. You could almost set your watch to it, if your watch were brave enough to admit that comets shouldn't behave like generators. ESA scientists call it periodic outgassing, but that phrase hides its strangeness. Outgassing, sure, all comets breathe when they near the sunday, but they do it chaotically, spasmodically, like old engines sputtering to life. 3I Atlas breathes like a monk, precise, patient, unbothered. The jets flare with mathematical regularity. Heat spikes rise and fall in perfect symmetry. It doesn't vent, it operates. One researcher compares it to a geothermal cycle. Another, quietly, says it looks more like a feedback loop, the kind you'd find in systems built to sustain themselves. Not explosion, not decay maintenance. It's as if, she writes in her notes, the object is checking its own pulse. You picture the surface up close, a dark, angular world of nickel frost and whispering gas. At regular intervals, something stirs beneath a shimmer of energy. invisible but disciplined. Jets of metallic vapor hiss outward, then stop, then start again, exactly 11 hours later. If you could hear it, it would sound like the slow exhale of a sleeping machine. In a conference call, a thermal engineer says what everyone's been thinking, but nobody dares to say. It's cycling power. The silence that follows lasts too long. Finally, a voice breaks through. Comets don't have power to cycle. Laughter, brief and brittle. But the idea doesn't leave the room. ESA's temperature graphs show a curious pattern. When the nickel plume rises, the overall surface temperature dips. When the plume fades, the temperature rises again. Inversion. Energy leaving, energy returning, like heat being pulled from one layer to another. A comet shouldn't regulate its temperature, but this one does, as if conserving itself. Meanwhile, the magnetic readings pulse in perfect step with the emissions. Every 11.2 hours, a soft twitch in the surrounding field, weak but exact. It's synchronized, says the magnetometer lead. What's synchronized? Asks her supervisor. Everything. It's at this point that even skeptics start to sweat. There's no known natural mechanism that could time itself this precisely over weeks of observation. Thermal oscillations drift. Chemical reactions lose coherence. Orbital dynamics wobble. Only something with active feedback could hold this pattern so tight. You could call it mechanical, but that feels too simple. It's intentional physics. Picture the scientists watching from their consoles. They know what their instruments are telling them, but their faces stay still, like poker players with bad hands. Someone mutters, "Could be resonant harmonics with solar flux." Another nods, grateful for the excuse. But deep down, they all know the truth: the sun doesn't hum in 11-hour intervals. The longer they watch, the clearer it becomes. The pattern isn't just repeating, it's adapting. After a minor solar flare, the interval shortens by half a minute, as though 3i Atlas adjusted for environmental change. Feedback stabilization, someone writes in the margin. A note for posterity, a euphemism for "it noticed." Back on Earth, in a late-night live stream watched by a few thousand insomniac skywatchers, a physicist overlays the emission data with human heartbeats. The waveform syncs disturbingly well. Peaks, troughs, recovery, rest. The audience chat explodes with jokes, space pacemaker, cosmic Fitbit, and the inevitable, "It's alive." The scientist smiles weakly and says, "No, just rhythmic." But even she can't stop glancing at the screen like it's listening. One theory gains quiet traction, that the emissions are part of a resource loop. Nickel and carbonyl gases vented and recaptured, processed in cycles to maintain equilibrium. It would explain the self-healing surface, the consistent luminosity, the refusal to decay. But it raises one unbearable question. To maintain equilibrium, for what? ESA's internal documents rename the event cyclic metallic activity. It sounds dull, like something that happens in dishwashers. But every analyst knows it's the first real evidence of machine-like consistency beyond Earth. Something in space that runs not on chance, but on rhythm. If you graph the cycle out, it looks almost peaceful. A slow heartbeat, stretched across infinity. No spikes of panic, no erratic pulses, just calm repetition. You could stare at that curve for hours, and part of you might start to understand the appeal of obedience. How stability can feel sacred when the rest of the universe is chaos. And maybe that's the point. Maybe 3i Atlas isn't powered by engines or radiation or something alien. Maybe it's powered by the same thing that keeps stars burning and planets spinning, the quiet compulsion to continue. the physics of persistence, the refusal to flinch. So every 11.2 hours, it exhales, not for propulsion, not for show, but for maintenance, like a cosmic sigh, releasing everything unnecessary before drawing in what remains. And in that rhythm, that patient, perfect pulse, the universe reveals its rarest secret. Not that something impossible exists, but that it's perfectly comfortable doing so. We have reached the end of the silent saga of 3I Atlas. The object, now traveling at escape velocity and receding into the blackness, leaves behind not answers, but the final, profound reality of the great silence. This silence is not the sound of an empty, uncaring cosmos. It is the sound of a universe so vast and so old that its communication is measured in millions of years, and its messengers are designed to be as quiet and as resilient as the stars themselves. The cosmic conversation, we realize, is not a radio broadcast. It is an implication, a subtle, non-gravitational push that gently suggests purpose. The first anomaly of the great silence is its completeness. We heard no signal, received no transmission, and saw no dramatic display. This complete quietude is the ultimate proof of advanced design. Any civilization that has endured for millions of years understands the energy cost and the security risk of a loud broadcast. The most effective message is the one that is embedded in the object's very existence, forcing the observer to deduce the intelligence behind the anomaly. The silence is the message. We are here, but we are patient. Find the proof in the physics. Imagine the feeling of profound loneliness that fueled the search for SETI for decades. The discovery of 3I Atlas and Oumuamua quietly alleviates that loneliness, replacing it with the subtle tension of being watched. The great silence becomes the sound of a patient observer, a silent auditor of our emerging civilization. The second anomaly is the enduring legacy of the object's shape. The probability that a thin, engineered film survived a 4 million year journey is vastly lower than the probability that a solid, dense rock survived. The fact that its behavior suggests the former is a powerful, final statement. The universe does not deal in the easy, it deals in the necessary. If the object had to be thin to be an effective light sail, then the civilization had to solve the impossible problem of making a thin film eternally durable. The enduring legacy of 3I Atlas is not its speed, but its tenacity. This leads us to the mythic link of the universal whisper. Ancient philosophers and mystics often claimed that the deepest truths were not spoken aloud, but were whispered to the soul. 3I Atlas is the universe's scientific whisper. It does not provide definitive proof, but it provides overwhelming circumstantial evidence that requires us to look beyond our immediate senses and trust the complex mathematics that governs the deep dark. Consider the final data point. As the object crosses the heliopause, the boundary where the solar wind gives way to the interstellar medium, its acceleration will cease to be dominated by solar radiation pressure. The final, persistent mystery is what happens next. Does its non-gravitational force drop to zero, confirming the passive light sail model, or does a new, subtle push, harnessing the magnetic or radiation fields of the galaxy, take over? We may never know the answer, but the unresolved fade into the void is the final, perfect ending to the mission. The viewer cue in this reflection is to carry the quiet wisdom of 3I Atlas with you. The most profound questions are often found in the most subtle observations. The universe is not a chaotic accident. It is a system of immense, patient purpose. The gentle closure is to accept that we may already be part of the experiment. the universe has delivered its quiet message. We are not alone, but we are incredibly young, and the conversation is only just beginning, taking place over timescales that stretch the human imagination. History bends, but never breaks. The light of the stars endures, and the quiet, engineered 3-eye atlas continues its solitary 4 million-year voyage into the heart of the great silence. And so, we leave the silent traveler to its 4 million-year journey. We have chased the ghost in the machine, following the subtle, unexplained push from the depths of Cetus out toward the edge of the Little Bear. We've learned that the universe often announces its most profound truths, not with a roar, but with a whisper, an anomaly measured in tiny meters per second squared. Remember the quiet humor in the cosmic scale. Our ancestors survived soup that might kill you, and we survived the realization that the most advanced technology might be a perfectly thin, patiently enduring piece of space litter. Tonight, let the tension of the unknowable relax into a profound, gentle gratitude. Be grateful for the complex physics that allows a sliver of light to push a small object across the eons, and for the tireless curiosity that allowed a small telescope in Hawaii to notice the impossible. The sky is vast, the night is long, and the greatest stories are often the ones that have yet to be fully written. Rest now, beneath the silent gaze of the cosmos, knowing that the journey continues, and the most important truths are found not in urgency, but in the quiet, enduring rhythm of deep time.